Alright, anyone from Instagram, welcome back. Anyone from YouTube, welcome. This is probably your first time seeing me. So, anyone who's been around will notice this is a different setting than normal. Normally I'm out in the shop. Today I'm filming in front of my book collection. We've got math books, welding books, machining stuff, quite a few engineering books, resource books. Got things like hydraulic controls, programmable logic controllers, books on electricity, Cad Design books, GD&T, blueprint reading, structural welding codes, applied strength of materials. I think there's a statics and strength of materials up there, basically the same thing. Yeah, so that's my books. I've been meaning to film an intro for the last, I don't know, month and a half, 2 months. I think more like a month and a half. My sister is actually holding a video that she edited for me hostage. She said she would not give me my video until it had a proper intro with me explaining who I am. So here I am. Hello. So my name's River. Let's see, what do I want to talk about? So what I'm doing, I am building a CNC router with auto tool change and plasma capabilities, as well as a new 70-inch by, what size of router am I building? One sec, I'll be right back. Okay, not 70. It's going to be 84 inches wide, so a whole 7 feet wide for the width, and it's going to be 18 feet long, so it's quite the monster. So that's what I'm doing, slab flattener and a CNC router with plasma. So my family, we're basically a bunch of super artistic creators that all really hated art class, which is kind of funny. So my dad, he runs a company called Stormer Hardwoods. He built his own 71-inch band sawmill, and he sells slabs, finished furniture, and is now also distributing both mass and eco-epoxy. And then my mom, she currently runs a business doing party decorations for baby showers and weddings, but she is now going to be transitioning more into the live edge work as well. She's getting into the ocean epoxy boards and some other stuff. The CNC router and plasma is actually for her, but it's going to be very nice because I get to use it whenever I want since I built it for free. And then my sister, my mom, her business Instagram is Native Timber Creations. I'll have my sister link both of the Instagrams somewhere. So my sister, she is also super creative. She wants to be a screenwriter, and she's even been on something called The Red List, which is actually pretty big. She has quite the talent for writing, but she also does all of our video editing. So most of anything interesting you see on my dad's page, Stormer Hardwoods, edited by her. Anything on my page that's complicated or fancy or goes to the beat of the music, probably her editing. And then all of the fancy stuff on my mom's page is mostly her editing. She does great editing. So that's my family. Alright, so a little bit about my education. So how I got into design and manufacturing like I have. Originally I just wanted to take a welding class because I noticed that on one of the video games I played it said that I put in 100 hours. And I was like, holy cow. And so I wanted to actually find out what could be accomplished with 100 hours of my time, like if I actually used it for something productive. So I signed up for a welding class at my college. I did running start, so I was actually still in high school. And I found out exactly what 100 hours of my time is worth, and haven't played a video game since. So originally when I was going through running start, I was actually going for an engineering degree. I was just going to do welding on the side in order to pay for my education instead of going into debt. And once I started working in the welding field, I realized that most engineers don't have any hands-on experience actually building things. So after a while, I decided to drop out of the engineering program and focus my full attention on the trades. So at the local trade school, they had degrees for welding, machining, mechatronics, Cad Design, and composites fabrication. So I decided I wanted to get all of those degrees instead of the engineering degree, and then possibly later go back to finish up the engineering degree after I had a lot of hands-on experience. So I learned a bunch about all of those fields from the trade school, Amtech, but I've also learned a bunch from just getting books and reading through it. Cat hair. But I've learned a bunch just from studying what probably are mostly college textbooks. I mean, there's some that probably aren't, but most of these books probably have been or are used in a college environment. And then I also get a lot of the education off of YouTube, fellow creators that do tutorials, different things about more advanced topics. I spend a boatload of time watching informational YouTube videos. Basically all of my free time I put into researching more about one of my chosen fields, whether that be mechatronics or Cad design. I just find a lot of it's even more entertaining than video games used to be for me. I love this. So a little bit about my field experience. So originally when I was going through the welding program at school, on winter break I got a job working for a mobile welding company, and they were doing some work on fishing boats. And we would work 12 to 16 hours a day doing just all sorts of crazy stuff, doing repairs on fishing vessels. Every day was a new thing to learn, and there were some people there that their knowledge of fabrication was just utterly ridiculous, and you could learn so much. And when you're working 6 to 7 days a week, 12 to 16 hours a day, you learn a lot. So my teachers at the welding school were cool enough to let me actually skip, I think, 3 weeks of the college course and still gave me credit for it, because I wanted to stay on at the boats because I was learning a little bit more than I was at college, because a lot more time, more experience, different projects. So that was super cool of them, and it helped me a lot. While I was on the boats, I got pretty lucky because I was the only guy around that could do TIG welding. And I was pretty new at TIG welding at the time still, but I was the only one with any experience. So I got to mostly run the TIG torch, and that kept me off of having to run the grinder too much. So I actually got a boatload of experience from working on the fishing boats. So after I got back from the boats, I continued with the college classes, and I also worked part-time at the mobile welding place doing structural steel, so I-beams, and then random repair stuff like on heavy equipment. And I eventually got into doing full-time work there as well as doing full-time at school. I just did more of evening classes and morning classes. And then at the same time of doing school and that job, on the weekends I actually got into making table legs for my father, because around that time, or before I even got into welding, he built his 72-inch, 71-inch bandsaw and got into doing the wood furniture. And after I started learning how to weld, he started having me make table legs for his furniture that he was building. And then I did that for a whole year. So I was doing school, mobile welding, and table legs on the weekend. And then come the next winter, I actually did the boat job stuff at a new company. I was actually what would you call that? I think you would call that a foreman. I had a group of welders that I was in charge of, and I had to coordinate projects and order material. And that was a huge learning experience. I was, 20 or 19 at the time, think I was 20. So that was a real fake it until you make it experience. Sometimes you just got to drop into the deep end and figure it out, and that was a huge learning experience for me. One of my shifts, I think it got to 36 hours we worked in a row because we had a deadline that we had to make. So that was quite the experience. And then after that boat season, a teacher of mine at the welding school, Amtech, he got me a job at an aerospace welding company, which was even more in the deep end, getting my skills up to aerospace welding quality. That was just a huge learning experience. There's always something you could learn there. But after about, I want to say like 3 months or so of me working there, they figured out that I knew how to do Cad Design. And lo and behold, I didn't weld too much there anymore. So I started doing a lot of tooling design for them. I got a short, like 10-minute tutorial on how to run a milling machine, and mostly had to self-teach myself how to design tooling for welding, tools and fixtures, and then I also had to make them. So that's what got me originally into machining, and it was a lot of YouTube to learn all that. So at that job, I spent most of my time doing tooling, design, and making, as well as like some custom projects. I did a stand for some old World War II military stuff, which was pretty cool. Got to work on some pretty interesting projects. But I would occasionally have to do production TIG welding for aerospace parts. That was a bit hard to not fall asleep for. We would make like 30,000 parts with an inch of weld on both sides. Very hard for my brain to stay awake. And then whilst I was still working at the aerospace place, my dad, he had a manual router sled that he built. It was ridiculously sized like normal. It was all steel. I think it was like 70 inches wide and probably 12 feet long, the base. And then he had a 3 horsepower router on it, and you would push this gantry back and forth. You'd push it an inch forward, slide a steel rack back and forth, push it forward, slide a steel rack. It was all steel on steel. Super hard to flatten anything. Like, it would take all day to flatten one dining room table. It's quite horrible to operate, and he eventually asked for me to put a power feed on. So we ended up working together, getting a gear motor and chain drive going so that the long axis on the machine had a power feed. And that power feed, we had a little motor controller. I think we probably got off of Amazon or something. Had the button of death. Like, if you holding that button for 10 minutes would make your thumb hurt for a whole day. Like, it was horrible to run. But shortly after having the long axis powered, so what we would do, we would run it down, run it back, loosen a clamp, slide it over an inch, clamp it, run it down, run it back, slide it over, clamp it, run it down, run it back. So we wasted time. We wasted about half the time having to draw it all the way back each time. So lo and behold, he then wanted to add a power feed to the other axis, the x-axis. So I ended up CAD designing up a little cart that could basically retrofit onto his pre-existing frame. So that sled was nothing fancy. So the retrofit cart, it had bearings, it worked pretty good, but the long axis I originally had just running on silicon bronze because I wasn't expecting it to be used as much as it ended up getting used. He eventually had me put bearings on the long axis as well, and for how hobcob that machine is, the finish that it leaves is just absolutely remarkable. Like, it leaves a dead flat finish. There's almost no step over lines. It's super easy to sand out. I'm still amazed that we run that, but once I put the axes on both directions, we actually made a control box. So I built it out of Arduino, and we have a little joystick on it. So my sister is the one who's ran it ever since the start of COVID, because she stopped working at the showroom that my dad had. So she sits down out there and she can actually, with just a joystick, run the machine back and forth and flatten the tops of slabs. It's running a Festool router still, so we manually lower it at each pass. She has a little shim that she uses so that it stays consistent. And then built into that Arduino controller, I have it so that there's just a 100% manual mode where it just goes where you say. And then I have a semi step over mode where if you flick it left or right, it'll actually move an exact distance each time. So the reason we never ended up finishing it is because I ended up learning about PLC controls, and I ended up deciding I wanted to make it 3-axis control instead of finishing the 2-axis. And I had all the designs ready to make a fully automatic slab flattener that was super simple to use. And a local guy that my dad sells wood to actually decided that he wanted a router sled. So I built the fully automatic one for him. It's a 10 horsepower, 12,000 RPM spindle. I'll have a video of it cutting. Somewhere, have that pop up. So what makes that new automated machine that I built so powerful is it has 3 modes. It has manual, semi-automatic, and fully automatic. So on the manual mode, forward and backwards works, just it goes when you tell it to. Left and right, same concept. And then Z, you can jog up and down either by holding the button and it jogging until you let go, or you can also type in how far you want it to move each time. So I have a little entry field where you click it and it gives you a couple options, or you can type in a custom value. So let's say you want each pass to be an 1/8 inch. You just type in 1/8 inch and then you jog around your table until you knock off all the high spots. Click the lower button and it'll automatically move down an 1/8 inch each time, and then you can just jog around again. And then the semi-automatic mode, it has that same concept with the up-down, but on the left-right. So how that's calculated is you have a field where you type in how big your cutter is. So you can type in, let's say you have a 3-inch cutter, and then there's another field that says what step over percentage do you want. So you can type in, let's say 70%. You want 70% of the width of the cutter stepped over each time. So then you can run your table like normal manually, but each time you step over, you just flick the joystick once and it moves over 70% of your cutter exactly. And you can jog it back, step it, jog it forward, step it. And by having that, instead of just guessing, your step over is consistent, and that makes it easier to sand the lines out if you have any lines on that machine. I had it built-in tramming so that you could get almost to where you couldn't even notice a step over line. Super easy to sand. And then that machine also has a fully automatic mode. So you have a couple of fields that you type in. So you have your cutter size, cutter step over percentage, you have your spindle RPM anywhere from 0, I don't know why you do 0, but 0 to 12,000 RPM. You have travel speed anywhere from 0 to 650 I think inches per minute. Then you have your step downs distance that you want, and then you have all those same fields for a finish pass. So I had the machine set up so that it'll deck off the most of the material, and then the last pass it'll actually calculate. So you can have it so that your RPMs are higher, your travel speed is slower, your step over percent is less, so let's say maybe like 50% instead of 70%. So you can, for the bulk of the material removal, you can have your machine hauling, and then just on the presumed last pass, it will change all the settings so that you can get a pass that is mostly focused on quality instead of speed. And So once you have all those fields typed in, you can just leave them there. And each time you set it up, you don't have to retype those values. So if you have those settings saved, they're just there. And so all you have to do when you go to flatten a slab is you type where you want to start, your near corner, and then you say how far you want it to go that way and how far you want it to go this way. And then you find your high point and you type in how low you want to go. Let's say you want to have a 2.5 inch thick slab, and you just hit go. And the machine will automatically go to the start point, lower itself, take the first pass, go back to the start, lower itself, take the next pass, go back to the start, lower itself, and then once it gets to the last pass, it'll change all the settings, including RPM. It'll automatically adjust that. It'll do a smaller cut. So let's say your roughing cuts are 1/8 inch, you can have your finish pass be at a 1/16 inch. And then it'll do the final finish cut and then go back to home, and your slab is ready to flip. And the benefit of that is you don't have to stand there the whole time. And unlike any other machine where you have to adjust it on each pass, that machine you could do 10 passes without you even being around. It can just be running in the background. And that's obviously very nice, because instead of having to either let a large investment just sit in the corner not being used, or having to hire a new employee to man it the entire time, you basically gain an employee instead of having to sacrifice one. So even if you're a one-man show, you can be flattening a whole slab while you're finish sanding the previous one. So you can just hit go, walk away, and you can be doing something else that actually makes you money, and you never have to let your machine sit there not making you money. You can always have a slab on it being flattened while you're busy doing other things. So a major focus of my business is to reason from first principles. So to basically strip down everything that's been done before and just reason from the ground up. So a lot of machines, they just copy what everyone else is doing, because that's how it's been done, that's how it's been known to work. For example, slab flatteners. Normally they use 6-inch cutters that are just bolted onto a 3-phase induction motor. That's how almost all slab flatteners work. I went a different route and I put a spindle on mine. Alright, so here's an example of what I mean by first principle reasoning. So with that concept, you basically have to dig down to the very, very, very root of something and work your way up. So how most companies go about things, they kind of look around at their competition and see what everyone else is doing, and then take that exact idea, maybe tweak it a little bit, and put their label on it. So you notice that a lot with slab flattening machines. They almost all utilize the exact same concept. They have a large induction motor with a gigantic custom carbide cutter bolted directly to the motor shaft. And that's most companies' claim to fame. Ooh, we have a 6-inch carbide cutter or 8-inch carbide cutter. Like that's what everyone pays attention to, and it's almost like a bragging right to have such a giant. Now, if you're looking at the idea of efficiency in like any one of these, like special machinery textbook or handbook, you can see just rocking a larger cutter is not the best way to actually increase productivity. And what they're actually doing, so their motors are stuck at either 1800 or 3600 RPM. That's what they got. They don't have any option to do belting or gearing because they're directly bolted to the motor shaft. So they can't spin any faster than what the motor spins from factory. So what they're doing is, so if they have, let's say, a 6-inch cutter, what they're doing is by expanding the diameter of their cutter, they're actually increasing the velocity of their cutting tooth, which is what is allowing them to travel. Because if they had a little tiny cutter, let's say a 2-inch cutter, and they're only spinning at 1800 RPMs, they can't travel very fast because they would have too large of a chip per tooth. So the ideal way to increase chip per tooth or minimize chip per tooth is to spin faster so that you can travel faster. It doesn't make sense to just make your cutter gigantic instead of increasing your RPM. So what I did is I went and found a concept where I could utilize a higher RPM so I could drop down to a smaller cutter but travel faster. So the concept of increasing your cutter size in order to be able to remove more material per minute is basically akin to taking a race car and building a race car, instead of putting a transmission in it or any gearing like in the differential, any of that, let's just put larger tires on. That'll make it go faster, bigger tires, which that's not really how the world works. You're going to lose torque, you're going to need a way bigger motor, and it's just more efficient to have your gearing change instead of just slapping bigger and bigger and bigger tires on to make you go faster. So what I came up with reasoning from the ground up is I wanted to have more RPM than what a normal induction motor 18 or 3600 RPM can offer me. So I went with a spindle system, and my original one gave me the option to go up to 12,000 RPM. And what that allowed me to do is to be able to utilize a smaller cutter. So I was able to put in a 3-inch carbide cutter and just spin that sucker up to a ridiculous RPM and then just send it. So I'm able to travel way faster, spin way faster, and I still have the horsepower. So most of the machines out there, they're anywhere from 3 to 5 horsepower. I think there's one out there that has 7 horsepower. My spindle has 10 horsepower. So if I wanted to, I could turn a 6-inch cutter, but that's not how you get peak efficiency. Having the smaller cutter that you can turn at a faster RPM and just traveling faster puts less torque on everything, so your cutter will deflect less and you'll actually get a smoother finish. And then the other thing with the finish, if you have a 6-inch cutter versus a 3-inch cutter and your machine is trammed with the same amount of error, the 6-inch cutter is going to have a larger step over line than a smaller cutter would. And I was able to figure out a way to almost completely remove the step over line anyway. I actually have a 2-bolt system that you can easily tram the cutter until there's almost no step over line very easily with just 2 bolts. But regardless, having the smaller cutter on gives you a nicer finish and way higher production than just slapping a giant cutter on. The other advantage to the new system that I came to from reasoning from the ground up is it has a collet system. So the advantage of the collet system is you can put any cutter you want in. The customer isn't stuck with just one cutter forever. What if the one cutter that you get with your slab flattening machine doesn't do good on epoxy? What do? So with my system, it has a collet system, so pretty much anything that you could put in a router or even a milling machine, you can put in my system and cut with it. And having the open ability to put any cutter in instead of having a proprietary cutter makes it much nicer for the customer. So that was a smarter way to go anyway, even if you didn't have the issue with the RPM. And then the next thing from reasoning from first principles, most slab flattening machines out there, and also most CNC machines, the side rails that your gantry rides back and forth on are normally the highest point of the table. And the issue with that is you can't forklift load anything. So back when my dad first started, I had to manhandle all these slabs on the table with him, and that sucks. We ended up having, I built a gantry beam above his router so that we have a winch that we can lift the slabs up and wheel it on. But the better concept is to just make the table forklift loadable. So what I did, I took those two side rails and I actually dropped them down. So my table, the highest point is the surface. The side rails that go along the edge of the machine are dropped down 8 inches, 6 to 8 inches, so that you can actually drive in with a forklift, set the slab down, back out, have your table flattened. Which is, when you're working with the size of projects that live edge furniture builders work with, like, you don't want to be manhandling a 14-foot slab of walnut or oak. So it was way harder to design the machine like that, but in the end, like, that's a way better concept. So instead of just doing it how everyone else was doing it, I reasoned from the ground up as someone with experience running those machines and realized, hey, I gotta find a way to make this thing forklift loadable. So that's what I did. And then I also have a bunch of other concepts on the machines that I reasoned from first principles, from the very bottom all the way up, instead of just copying how other people are doing it. So that's going to be a large focus of my channel and my business, is taking concepts all the way down to the root cause and coming up with things that have never been done before. And I actually have quite a ridiculously large list of machines that I'm planning on doing this on. Alright, so something I came up with, which took me, 2 years to invent. It's very hard to reason from first principles and to figure something out brand new that's never been done before from the ground up. But the concept that I came up with is to solve the issue of large-scale CNC routers and plasmas being outrageously priced. Because we're able to make, there's several companies out there that can make hobby-grade machines, but there's no ability for them to really make a quality light industrial machine that's large scale. So your two basic concepts is to bolt extruded aluminum together and just copy whatever precision you have in your extruded aluminum, and that works for the hobby grade. It's not good enough for the light industrial machines. And how light industrial machines normally do it is they have multi-million dollar bed milling machines or gantry milling machines, and they'll actually have a CNC machine that can machine their CNC router base all in one shot. They're huge, like they fill up an entire warehouse. I mean, the concrete that goes under their machine probably costs a few $100,000, I would presume. So what that ends up doing is their price on their machines has to be outrageous to be able to afford the tools that they have to have in order to make the machines. So I came up with a piece of hardware that allows me to align my machines perfect, completely separate of the actual accuracy of the frame. So the precision on my my bases, my frames, they don't matter, because I can perfectly align with my hardware that I designed the linear axes, and then I can take a cutter and actually deck off the top of the table. So what that allows me to do is to make a large scale CNC router or plasma table with very limited technology. Like, I can do it on a manual mill and lathe. I can make small parts and then align them either with hydro levels, or even if I wanted to get more precise, laser leveling. And I can make a very highly accurate CNC router or CNC plasma at almost any size with this concept. So that's going to be a big one. I've never seen it done before. Super excited to see how it turns out. That's what's allowing me to build the slab flattener that's at 18 feet long, and I'm going to be able to level that thing dead flat the entire way. And the main point of this channel is going to be following me building several different types of machines, and I'm going to try to reason from first principles and come up with new concepts on as much of the systems as I can. So we've got the slab flatteners, CNC routers with auto tool change, plasma tables. I want to build a swing saw, so that's basically a sawmill that utilizes a circular blade, and it allows you to rotate it. I have a couple of cool concepts that I want to try out that I haven't seen done before. That'll probably be my next machine build. After that, I'm going to rebuild my dad's band sawmill. I have a couple of really awesome concepts already sketched out and ready to go for that. And then eventually I want to get into doing things like CO2 lasers, and a super dream project of mine would actually be to build a water jet, CNC water jet. So I think that's all of the things I had to talk about. So now I have to compile these clips, and hopefully my sister will give me my video that she edited me, because now I actually have an intro for her, which only took me a month and a half to film. And hope you enjoyed. See you next time.